All right, let's go over a couple of the uses that nuclear radiation has, especially regarding the medical field. So we already talked about radiation treatment for cancer. Here is one type of that. So brachytherapy is when a seed, a very small amount of radioisotope encased in, it could be encased in a small metal shell, and could be planted into a tumor or a tissue with a recently removed tumor, and that small seed will emit some radiation and do targeted damage to the cancer cells that are in that tissue. So we have a treatment with radioactivity is a treatment that unfortunately we are already familiar with for treatment of cancer. Other things that in the medical field that involve radioactivity are some types of imaging, some types of scans. One of these types of medical imaging is called positron emission tomography, or PET scans. Also CT scans, computed tomography, use radiation. For the positron emission, some sort of isotope is administered that decays to emit positrons. Positrons, again, these are antimatter. They do not live long. They immediately encounter another piece of matter in the body, and then they are destroyed and they emit gamma radiation. Gamma radiation is energetic enough to be detected by, used to be photographic plates. Now we have these electronic detectors that can detect gamma radiation, and the detectors are placed in a 3D array so that the computer can use the signals to compute the 3D image of what was emitting the positrons. X-rays are another type of high energy radiation that can be detected by computers and made into a series of images. The actual PET scans have an actual radioisotope that emits the gamma radiation that causes the imaging to take place. The CT scan does not involve a radioisotope. The X-rays, the high energy radiation, does not come from a radioisotope. It is generated outside the body and just kind of sent through the body. So any kind of X-ray is like that. You don't actually ingest or get injected with a radioisotope to get an X-ray. So these are just X-rays being irradiated at the body, and then the pattern that they create when they're absorbed by different parts of tissue, different types of tissue, is made into images with computer calculations. Another type of scan that does not involve radioactivity or high energy X-rays is magnetic resonance imaging, so MRI, and that involves a powerful magnet. The hydrogen atom nuclei are aligned with a powerful magnet, and then energy in the form of radio waves is pulsed at those aligned atoms, and then the absorption of that energy can be made into an image. So besides some of these imaging techniques and treatment of cancer, there are other non-medical uses of nuclear radiation that are nonetheless fairly common in our lives. We do have nuclear energy as a source of power. So we have controlled nuclear reactions that are generating heat, converting water to steam. So instead of burning wood or burning gas or burning oil, the heat from a nuclear reaction can convert water to steam, which drives turbines and produces electricity. We also use nuclear radiation to kill bacteria, kill microorganisms on some foods to increase their shelf life. This does not make the food itself radioactive. It's just kind of like when you get an X-ray, some high energy beams are sent through you. So these high energy gamma radiation is sent through the food, but the food itself does not become radioactive. It's just that the high energy kills the microorganisms that are on the food. And then another use of radioactivity that you may have heard about, this one having to do with the half-life that we were talking about, is radioisotope dating. So all of our all the problems that had to do with half-life were talking about figuring out how old something is. How old is something if a certain number of half-lives have passed. And then the number of half-lives that have passed affects the amount of radioisotope that remains. The amount remaining is the original amount times 1/2 to the n power. So if you remember that equation with that had to do with half-lives, we were determining the amount remaining, knowing how many half-lives had passed. We could take the original amount and cut it in half that many times. If you know the original amount and the amount remaining, you can figure out the number of half-lives that have passed for a sample, and you can figure out how old the sample is. Carbon-14 has a half-life of 5,730 years, so it is useful for being able to figure out the age of things that are thousands of years old, or at least hundreds of years old. So these are some medical and non-medical uses of nuclear radiation.